Today's lesson is on rational expressions. We're just going to be multiplying, dividing, adding, and subtracting them. This should be a review from Algebra 2. So I'll go over it quickly. So we're going to start looking at multiplication. So x plus 3 over x squared minus 4x plus 4 times x squared minus x minus 2 over x squared plus 4x plus 3. A reminder that when we're multiplying fractions, you just multiply straight across. However, let's look at if we can factor all of these quadratics. Okay, so x plus 3 over this will go down to x minus 2 times x minus 2. And then times, let's see, up here I'll have x minus 2, x plus 1. And then x plus 3 times x plus 1. So we're multiplying straight across. Really what we can do is I like to just extend my line because this is all just a bunch of multiplication here. Okay, so when things are separated by multiplication, we can cancel out. So x minus 2 and x minus 2 would cancel. X plus 3 cancels. X plus 1 cancels. So everything cancels in the numerator, so that's 1 over. In the denominator, all I have left is x minus 2. All right, similar concept, except now we are dividing. And all you need to remember is when you're dividing fractions, we change to multiplication, and we flip. Keep, change, flip. So as I do the keep, change, flip, I am also going to be factoring. So let's factor the top. That will be x minus 6 and x plus 1. The denominator, I'm going to factor GCF out. So 2 times x plus 3. And then times, okay, I've got the flip. So this denominator is going to be in my numerator, and I'm going to factor a 4 out, so I'll have x plus 3. And now factoring the numerator to put in the denominator, that will be x minus 4 times x plus 1. Okay, so I'm going to put this all together. You can probably skip this step, but I'm just going to rewrite it with my coefficients out in front. And then x minus 6, all of my binomials next to each other. Okay, so now I like the coefficients out in front because then I can see how to simplify there. Let's see, I've got x plus 3's will cancel, x plus 1's cancel. So 4 divided by 2, I've got 2 times x minus 6 over x minus 4. Nothing else cancels. You could leave your answer like this. You can also redistribute the 2 in. So you'll have 2x minus 12 over x minus 4. Either one. All right, so now I'm into adding rational expressions. So to add fractions, you need a common denominator. And before I decide what that common denominator is going to be, I need to factor anything that I can. So 3 over y plus 5 plus y over, this factors to y plus 5 times y plus 2. So to get a common denominator, they both have the y plus 5. The left side's missing that y plus 2. So I'm just going to multiply top and bottom by y plus 2. Numerator, I'll distribute. Here, I'm just going to leave my binomials separate. So when you distribute, we get this. So now when you are adding fractions, and once you have a common denominator, remember you're going to add the numerators. So that would equal 4y plus 6 over, you keep the denominator, y plus 2 times y plus 5. And usually after here you're done, but sometimes you just have to check to see if after you combine, if you can factor the numerator. So here we could factor a 2 out, which would leave us with 2y plus 3, but that doesn't actually help us cancel anything with the denominator, so really we don't need to do this step this time, and that can be your final answer. All right, and my last example is subtracting, which is basically the same as adding, but it gives us another example to do. So 6 over x plus 8 minus 3 over x plus 3. So common denominator, we're going to take this denominator, x plus 3, and multiply top and bottom here, and then take the x plus 8 and multiply that over here. Okay, so on both sides, I'm going to distribute. But when you have subtraction, I want you to think add the opposite and distribute a -3. So I will have 6x squared plus 18x and minus 3x minus 24. And then once I have that common denominator, I can just combine my numerator. So I will have 6x squared plus 15x minus 24 over x plus 3, x plus 8. And then you often will have to look to see if the numerator can factor. In this case, it does not. I could factor 3 out, but that's not going to help me with anything. So I can leave my final answer just like that. So there's your quick review on operations with rational expressions. Good luck.